So for us to make radiology software simpler, smarter, and more scalable, we had to start from scratch with a revolutionary new architecture. This required 5 years and nearly $100 million of R&D and a whole lot of really smart folks to help build it. And it really is an incredible combination of modern software and cloud-native infrastructure. It is a complete reinvention of radiology IT as we know it, and I can't wait to share it with you here in a few minutes. But first, let's talk about why radiology's future requires this reinvention. So here are some of the leading PACS and reporting products on the market today. For private practices, these are probably the usual suspects. You got IntelliRad and Philips for PACS, you got PowerScribe and Fluency for dictation, but it doesn't really matter for the point I'm gonna make. They're all pretty much the same. And let's say, like most practices, you don't get the luxury of reading off of just one platform, but you gotta read off of multiple PACS and reporting platforms. Maybe you got one for the hospital, maybe you got one for your outpatient work. Let's say you've made the investment to make your software a little bit smarter, so you've got an AI algorithm or two deployed. And let's say you bought a universal work list like Clario to help you string all this together intelligently. This is pretty much as smart and as easy to use as software in radiology gets today. Now, yeah, that's a whole lot of stuff for one IT team to have to manage, and there's no question that all of these products, they have their strengths and they have their weaknesses. But the real problem isn't actually any of what you can see here. The problem isn't actually any of the products that you buy. The real problem is what is underneath all of this. The first problem is the complexity of stitching all this stuff together because it's fragmented. And the second problem is that all of the software in radiology was built on top of really ancient technology and infrastructure. And when you put these two things together, you get a whole lot of complexity that keeps IT teams up late at night fighting fires, and you get some really not so smart and not so scalable software that keeps physicians up at night reading for longer hours than they should have to. So if the problem with software in radiology is all these old boxes and all these brittle connections, here's what we're gonna do. We're gonna take all this and we're gonna replace all of it with a single URL. All the tools that you need to practice radiology more efficiently and more effectively in one single website. So how are we going to interact with this website? Are we going to do it from behind the same 10-year-old VPN-connected, hamstrung PC workstations that still run Windows 10 for some godforsaken reason and can only be accessed by literally driving yourself to the hospital and sitting physically in the basement? Why on earth would we do that? Who wants to travel to physical workstations or swivel chair around to multiple PACS systems on multiple computers? Who wants the IT hassle of managing workstations and VPNs and Windows apps and all of this craziness? Nobody wants any of this stuff. So instead of designing our platform to run in one place and on one kind of computer that you gotta lock down in order to secure, we're gonna build it to work on every computer from anywhere in the world all the time. We're gonna use this platform the same way we use everything else in our digital lives. We're gonna use it through the most powerful and the most ubiquitous IT platform ever built. We're gonna use it through the web browser. Specifically, we're gonna use it through Google Chrome or any Chromium-based browser. And we're gonna use it wherever, whenever we want, and with diagnostic-grade performance. So to do all this, we had to invent a new technology to power it all. We call it RadOS, and it's the first of a new kind of software in radiology that we call the Radiology Operating System. It's the first brand new technology introduced into radiology IT in well over a decade. Here is all that you need to know about RadOS. It's radiology's first cloud-native platform, meaning we built it from the ground up, specifically for the cloud. It can be overlaid on top of as many modalities and PACS systems, RIS systems, and EMRs as you have, all the DICOM and HL7 feeds that drive your practice. RadOS then ingests all this data. It uses a proprietary AI system to normalize that data, solving the data heterogeneity problem, so you get things like hanging protocols that work reliably for the first time. And it uses Sirona's proprietary ontology that we call SironaLex in order to map all of this normalized data to a knowledge graph of radiology-specific knowledge. And then we use this clinical understanding to help orchestrate all the AI and all the other software tools to help you practice medicine faster and more effectively. RadOS then distributes the data that each radiologist needs to the closest of 550 edge locations all across the world, whichever's going to be closest to the radiologist at the time that they're reading, which helps to make load times fast and consistent from anywhere in the country and over time from anywhere in the world. A real-time data intelligence engine logs every event across the entire RadOS infrastructure. Every case that's ingested, every click, every word spoken that we got wrong from a speech-to-text perspective, every image that didn't load as fast as it should have. All of this information is logged so that we can make sure that every physician has the same awesome experience using our platform. Then, RadOS archives all this data for 10 times cheaper than has been possible before. RadOS also makes Sirona's platform really, truly future-proof for the first time. Today's radiology IT solutions were built as what are called monolithic systems. This architecture was really how every software was built 10 to 20 years ago, and it means that their entire code base is kind of like a solid brick wall. Trying to improve any one part of the system is like trying to cut out a brick and then replace it. It's difficult, it's time-consuming, and it breaks all sorts of stuff around it that you didn't mean to. Physicians today know exactly what this feels like in two ways. It's the reason legacy vendors build so damn slowly, and it's also the reason every upgrade always breaks something that wasn't broken before. It's a moratorium on innovation, which is why software engineers stopped building systems in this way over a decade ago. You can't modernize them brick by brick, so you really can't modernize them at all. So we built RadOS in a totally different way. We built RadOS in the way all modern software is built today, on a microservices-based architecture, which is kind of like putting a bunch of Legos together. It's a bunch of independent pieces that are all tied together in a really standardized way. This means anytime you want to improve or modernize one piece of the platform, like say how we store images, we can just swap out that service for a more modern one. Anytime you want to add new capabilities, like say you wanted to add a module that allowed us to ingest genetic data alongside imaging and run all the same powerful RadOS platform functions on that data too, well, in effect, you can just add another Lego. You can just add modules as complex as this, and you can do it without worrying if it's going to break everything around it. You can continuously modernize the system piece by piece.